log rules.
Mm-hmm.
The first one that you have looks probably something like this. It is log A times log B is equals to, no, it's not times, it's plus log B is equals to log AB, right?
Okay.
Okay, now we normally say that, and one very important thing about logs is that logs, right, is always, okay, let's use different letters. Let's say C and D, right, equals to E. We understand that log, you always have like a base, right? Then this is the actual value,
Mm.
right? And this here is actually the exponent. Sorry?
Mm-hmm. Yeah, I was saying exponent.
Yeah, right? So for
Mm.
this here, if we want to convert it to an exponential function, it's just writing CE to the power
Equals
E
D.
is equals to D.
Mm-hmm.
You understand me? Or this one here, right, which is log A over B. Which other one again do you guys use? Okay, maybe this one. Not looking. I think it's okay. Yeah, something like this. Log AB is the same thing as saying log B over log A. So
Okay.
what that means is that if you have a question that just has maybe log 5, 6 plus log 5 root x, because they have the same base, we can just say that this answer here is log 5. 1 minute. Log 5, 6 root x, right? They can just multiply.
Okay.
Are you getting me? Right? So that's basically what it's telling us. As far you have the same bases, right? And there's an addition. It's just like, you remember when you had the exponential rules?
Oh,
Yeah?
like multiplying the. Okay, let's see. Let's see.
You remember this now, right?
Yes.
That
2 plus
whenever the
3.
bases are the same, instinctively you know you just have to add.
Mm.
Do you understand? That is the same thing you need to think about when you're thinking of this question, when you're trying to answer this type of questions.
Okay.
Is that making sense on that?
Yes, sir.
Okay, so that's exactly what they understand by, and the same thing is also involved here, regardless for the second one. So, crazy question. Let's say you need to split it. You have like log 3y beyond this. Oh, sorry. Log y over 3. We understand that this is just the same thing as saying log y minus log 3. Now, you are allowed to give it its base. So, if this is like 10, also we don't write 10. So if this is like 9, then you can also give this 9 and give this 9, regardless of what the question is.
Mm.
Does that make
Okay.
sense?
Yes, sir.
Okay, so that is, to be honest, that is all what log rules are. Okay, you ready?
Yes.
So how would you approach a question like this? Which says, refer to the figure below that shows a sketch of y is equals to gx and y is equals to g negative to the power of negative 1x. I think that's the inverse of gx, where gx is equals to bx. Now T is the point of intersection of the two graphs, and the point K, which lies between negative 1 and 2, is on the graph. Now show that B, actually I said that wrong, the point K, negative 1 and 2 lies on the graph. I don't know what I was saying before. Then they said show that B is equals to half. Okay? So we need to show in this question here that B is equals to half. As you can see, B is this one over here, right? And it's the exponential part. I'm guessing this is not so much of a problem. Tell me what I'm going to do real quick.
Just solving the point.
Solving the point, exactly. So it is y is equals to b, oh sorry, so I need to solve it first. Let me just put it once off. So y would be, so we are solving k,
K.
right? So y
Yes.
would be 2 is equals to b to the power of negative 1. So therefore we know that b will be equals to 1 over 2, right?
Mm-hmm.
Yeah. Do you agree with that?
Wait. I
Or even apart from
wait.
that, okay, think about it. It is 2 is equals to 1 over b because
B.
negative 1 means the inverse, right?
Yes.
And you cross
Uh,
multiply, b
and then
goes there,
cross.
2
Yeah.
goes there. Exactly. Then that gives
Yeah.
you that.
Okay.
Do you understand it now?
Yes, sir.
Okay. Now they said determine the equation of the inverse in form of the inverse is equals to, right? So
Mm-hmm.
obviously with inverse, we said that we normally do what?
Swap the X and the Y.
We swap the x and the y, right? So the x becomes, so the original equation is y is equals to
Half to the X
half to the x, then it becomes x is
equals to
equals
half.
to half to the y, right?
Mm-hmm.
Now,
That makes
you just need to use your skills of changing from exponents to logs to help you get this, right? So the power becomes the actual value. So it is y is equals to the log,
log of a
right, of
half
half x.
X
Okay, so they want it in this format, you can just say that is equals to the log of half
of
x, right? So that would be like your last sentence. Does that make sense?
yes, sir.
Okay. Now 3 now says the coordinate of t is 0 and 64. That's wrong. The x coordinate of t is 0, 64. Give the y coordinate of t and correct two decimal places. Oh yeah, okay, so here that's like the point of intersection,
Mm-hmm.
right? So what do you think we do to find our point of intersection?
Equate both equations.
You will do that. Okay, but normally if you don't have the x and you don't have the y, you're absolutely right. You equate both equations and it helps you get your x. And remember, your x helps you get your y, right?
Mm.
So now, how will you get your y if you already have the x? Do you still need to equate both equations? What do you think?
Wouldn't you equate but then sub in the X?
You only need to remember, how do we normally find y usually? By just subbing in the x.
Mm.
Since you already have the
Oh, so just
x,
subbing in the X.
exactly. Since you already have the x, you don't need to do that whole thing again, right? So
Mm.
I'm just going to take, I can take any of the equation, but probably we'll take the easier one, right? So it says y is equals to half to the x. So it is half to the 0, 0.64. So what does that give you?
0.64.
Half to the power 0, 0.64 also gives you 0, 0.64.
Yes.
Oh, wow. Okay. 0, 0.64. That's a crazy one. And when we're done, I'll check the memo to see if I hope I haven't taught you something wrong. For question 4, they said write down the values for x for which the inverse is greater than 0. Okay. So we did this last year though, but let's see if you still remember. So the inverse is greater than 0. How do we go about this real quick?
The inverse is greater than 0, so we look at the x-intercept.
Exactly, right? The part of your graph that is above the x-axis. So that is your x-intercept from x-intercept upwards, right?
Mm-hmm.
So what will be your answer? Or what do you need to get
X,
first for you to get your answer?
yeah, x-intercept.
Okay, so let's start with that, right? Before we start going crazy, let's start with that first of all. So we know that the equation for this is y is equals to, you know what? No, we don't need all that. So how else do you think we can find our x-intercept without actually finding our x-intercept from here?
We know our thing is 0. Hmm?
So you can see, don't get me wrong, right? You can go through the long process of substituting y as 0, then getting your x-intercept. You will get the answer. But what do you
Yeah.
think is like a shorter way of doing that so that we don't go through all the process of doing all this? I remember, another thing, I'll give you a hint. Remember, we're working with inverses.
Oh, okay.
Do you
So
get it
we
now?
know the x-intercept of, if we know the y-intercept of the other graph,
Exactly. That
we
will be the
know
x-intercept here. And clearly,
intercept.
because you see there's no asymptote or anything, what will be your y-intercept for this?
Wait, what's the, so half to the x, so it's 1.
Is 1 exactly, right? Because it just be half to the 0, which is 1. Anything to the power
Mm.
0 is 1, yeah? So it would mean that we already know our
1 and
x-intercept
0.
for this
1 and 0.
would be 1.
Okay.
Okay, so that saves you the time of doing complex maths for no reason. So we know
Mm.
this one here is 1. Now we
Yeah.
know that this is 1. How do we now find which part of our graph would be greater? It was greater, right? Yes,
Yeah.
would be greater or equals to 0.
So where g, the inverse of g at x
Yeah,
is,
remember, focusing on the inverse of gx. Yeah,
but the values of x,
the values of x. Yeah,
yeah, so x is less than or equals to 1,
okay,
but but x is greater than 0
absolutely right. But why did we say it was greater than 0 though?
because the asymptote.
Exactly, it doesn't pass the asymptote, right? So we know that it's definitely going to be greater than 0, but it doesn't also go past 1, but it actually touches 1. Now, since the question is asking us greater or equals to, right? We can say that we'll have x would be um,
Less
less,
than.
right? Or equals to 1, but just x will be
Greater.
greater than 0. But there's not, it cannot be c, because since it cannot touch the 0, we can't say it's greater or equals to 0.
Mm.
Do you agree with that assessment?
Yes,
Okay, now we go to this here, which says hx is the reflection of the inverse about the y-axis. Give
hmm
the equation of hx. So what does reflection about the y-axis mean again?
the x value will be negative.
Sorry?
The x value will be negative.
Exactly, right? So basically we're saying xy become x negative y, right? So in this case
No,
here,
x is a negative x and
oh,
y.
good gracious. Mm-hmm. Been saying that this guy is smarter than me.
Nah.
Negative one, negative. I think I need to put it on that side. There we go. Negative like this. Okay. So if that's the case here, we are saying that let's write this out. The inverse, right? The inverse was y is equals to log half x.
hmm
So the x part to be negative, right? So we are putting a negative here. Okay, but do we just end it there? That actually I think we do. Hold on. Wait, negative. Let me write this up properly. Because again it is 1 mark. I was thinking I need to simplify a bit though, but since it is 1 mark, I don't think, yeah, I don't think we can do much to this. Because normally, mm, yeah, no, I don't think we can do much to this. It's 1 mark. No, there's no calculation we can do. Unless it was more than 1 mark, then we probably would have done more things. But for now, it's fine. Okay, now they say state the domain of hx. So how do you think we can state the domain of hx? What should we do?
Main.
Sorry.
So we know
Okay, and by the way, remember hx is the reflection of the inverse. So this is your inverse here.
okay,
So
so we know it's less than zero.
sorry,
It's less than zero.
is less
X
than
is like
zero.
yeah.
Okay. Okay, so okay, you're absolutely right. Yeah. Normally with questions like this, it's better to look at the original, then walk your way from there. If you wanted to
Yeah.
get a domain of this inverse, what would your answer have been?
X is greater than zero.
Exactly. Yeah, there you go. So it's obviously going to be there. If you draw it, let's say you kind of sketch one. That's a horrible looking graph. So it's going to be something like that, right? Yeah,
Yes.
that's how it's going to reflect on that side. Yeah, I need to be less than zero. You're right. Um, okay, so this one here would be x is less than zero. Was that the last question here? Yes, it was. Okay, so let me see if I haven't been spouting nonsense for the past 10 minutes. Let's see the answers here in the memo. One moment.
Did you see we beat Arsenal?
I thought you said you're an Arsenal fan, dude.
Uh, I support two teams.
I what? I what? Didn't you say you're an Arsenal fan?
I'm an Arsenal fan sometimes, depending on the
Now, Man City is at the top of the table again. It's
mm,
like everything is right with the world.
order has been restored.
It's crazy, man. It's really, really crazy. And I was, to be honest, I was actually rooting for Arsenal that at least, at least something, okay, everything is right.